Hi, and welcome back to Enlargements. Today we're going to do fractional scale factors with center not at the origin. So we've done fractional scale factors, we've done centers not at the origin. We're just going to do them both together, so it's nothing too new. So first, mark our center at 4, 3 for the x, 3 in the y. Okay, so I'm going to start putting a little C because some people can start getting confused with all the lines and all the information on the page. So it can help. Next thing we're going to do, well, we want to find one of our closest points and make our horizontal and vertical lines so we can find where our starting point is going to be. We notice that it is 4 and 5 for our measurements there, and we can find that 5 times by 1/2 is simply 5 halves, and we'll leave it like that. And we'll do 4 times 1/2, which is simply 2. So we can make our new point, which I'm going to do in red. From our center, we're going to go 5 halves down. So 5 halves down is here, and then we're going to go 2 over. So that is our new bottom right, or top right corner. Sorry. Now if we look at our actual shape that we started with, it was 4 and 2. So we know half of 4 is going to be 2, but half of 2 is simply 1. So we have all the measurements we need now, and I'm just going to start drawing our lines. So we have our first point. We're going to go from here over 2 spaces. Then we're going to go down one space, right? And then we're going to go over, back up. I'm just going to move that one line up a little. I want to try and be as accurate as possible when we're drawing our lines. Now we can check with our lines to make sure that they land on what we're looking for. So we've got our one line, got a second line, it lines up, our third line, and we can draw our fourth line in there as well. So it lines up indeed. So our next example we're going to do, we have to once again indicate our center. So our center here is -1, -2, -1, -2, center down here. This one I'm going to draw my lines to begin with because it's a different kind of looking shape that we don't use too often. So drawing a couple of these lines can help us out. Next off, we are going to pick one of our points. So I'm going to pick our closest point and make a horizontal and vertical line. Let's label them. They're both 2, so 2 up and 2 across. So 2 times by our scale factor of 3/2 is going to result with 3. So that means from our center, we're going to go 3, 3 over, 3 up. So 3 over and 3 up is going to take us right here, which lines on one of our dotted lines, which is great. Actually in line with our other vertex, which is even better. So now what do we want to do? Well, let's look at our bottom over here. It was 2, and we know that 2 becomes 3. So we're going to count 1, 2, 3 over. That'll be our next point. Then we can label up our right side, working anti-clockwise. And so we notice that it's 2 up. So 2 up is going to become 3 up, which is lines on our next intersection point. Then we have 1 over. Well, 1 over, 1 times 3/2 is simply going to be 3/2, correct? So we're just going to move 3/2 over, which lands directly on our other dotted line. So these dotted lines are really coming in handy this time. Should write that more as a 1 there. So we have one more thing we can do. Well, it's 1 down. So 1 down is 3/2 down, which lands there, which is great because now we have all the points we need and we can just connect them all with our lines. So grab out your straight edge and start connecting your lines. And if you notice, all of our vertexes did line up, which is good. Now there's a couple problems for you to practice here. So if you want to, pause the video now, and then once you're ready, we'll come back and do these questions. All right. So first off, we have to do is we're going to mark the center as -1 and 3 for our left question. So -1 in the x, 3 in the y. So here we want to draw over to one point. I'm going to choose this point right here so that we can see that that is 3 in our x and 1, 2, 3, 4 in our y. So our that point, instead of being 3, it's going to be 3/2. So we just half that. And then we go 2 down. So that is that new point. Now, instead of being 1, 2, 2, 1, 1, and 1, these are going to become, well, if that's our point, we're going to go 1/2 over from our point to the top right corner. Then we're going to go, instead of going 2 down, we're going 1 down. So going 2 over, 1/2 up, 1/2 over, and we can draw our line now. And we're done. First one. So if we look at our right one, now we have to mark our center again. So 3, 3. It lands right at that point, which is actually on our diagram. So we actually call these, if you remember, invariant points. So a point that does not change its location under a transformation is called invariant. So it's invariant when it's not changed. Which, if you think about it, we get from invariant we have variant, which means change, right? Something varies, if we have a variance in something, it means change. So invariant is not changed. Anyways, little English lesson. So here, once again, what do we do as our next step? Well, we want to take a point. I'm going to take this top left point, and we're going to see that it's 1 away, 1 up. So we have our scale factor 3/2. So we've done this before. We know that we're going to go 3/2 over, 3/2 up. So 3/2 over, 3/2 up. That's our new point. Now, to get our next one, it's 2 down. So we know that's going to become 3 down. So 1, 2, 3 down is there. And then instead of being 2 over, it's 1, 2, 3 over. Right? Let's connect our dots. And we'll call these problems a day.